Hey, this is Team System 6 back at it again. This is for our final project. Sad to see it go, but we're happy with all the things that we learned that we'll use in our future. Alright, let's get to it. First, LCD monitor looking nice. Bluetooth module, H10. Got our motor with a little fan on it, H-bridge. Battery pack, 9-volt battery, MCU board. MSP430FR2355, looking good. Alright, so what we're going to do, we're going to have our timer B set up, normal timer for our capture compare register 0 and register 1. Timer B1, what we're going to use that for is when the user presses the first button and our UART receiving buffer gets the first character, it's going to initialize a timer B1, and each time it gets a character and replaces a character, it just resets the timer. But once that final timer finishes, it's going to trigger a timer which sets is complete equal to 1, which will get out of this infinite while loop, which will come down here. And if it is complete, that means that the user entered some values and that the buffer is empty. So whatever is in this entered value variable that got filled up, it's going to be placed into CCR1. However, if the value is greater than 100 or 100, we just lower the flag because that just means that the motor is just not going to get turned off at all. So there's no need to turning it off. And as you can see, timer C file we have the basic timer B0 set up. Timer B1, that's our special timer that's going to wait about 3,500 overflows before it finally flips that flag. And then also want to come back here, and as you can see here in this bottom line, once this flag does trigger from timer B1, it's just going to set is complete equal to 1. And we can see that after everything is all said and done, and our new PWM time frame has been set, it's going to get set to the screen, and then we're going to lower those flags, disable the interrupt enable until a new value is entered, and then reset that entered value, and then set our flag is complete back to 0, which will send this while loop back to spinning. And then we also have a liquid crystal file, standard file that you guys sent us over, let us use. And then our Bluetooth module, which just initializes the UART, setting in a software reset, selects the clock, the bit rate, and here's our baud rate, 9200. And then we're putting our pin 1.6 into receive mode. So our Bluetooth module H10 is going to transmit a signal to the receive mode serially, asynchronously. And then we're going to take it out of software reset and then enable that interrupt for when something gets into the buffer. And then this is our what happens when that flag gets set. We just store the value in the buffer. It's just going to be some character. If that is a character that is greater than 0 but less than 9, so it's an actual digit, we're going to set the entered value. We just multiply it by 10. This is pretty much just you get a number, you get a new number, you shift it to the left, you add that number to it, and it just builds a number in a nice way. And then each time that this happens, we're going to enable the TB1 so that timer starts going, and it's letting them know that when that timer does complete, it's going to flip that flag and set is complete to 1. And then each time this function is called, it just resets the timer so that it doesn't flip that flag and set is complete too soon. So all right, let's see this bad boy in action. All right, so as you can see, we are connected here, and that just means that this is a solid orange light, looking good. Right now we're at 0%. Let's go ahead and type in 25. As you can see on my phone, 25%. I'll press send. The fan starts going. The value is 25. I'm getting a little closer for you. Good. All right, let's try 50%. Nice. Pretty quick on the draw. 75. And then let's go 100%. We'll also do a quick value to see what happens if we go over. Let's do 899. Why not? It just maxed out at 100. Nice and clean. Pretty simple. It was a good semester.